Hello and welcome to the Web for Data Science video tutorial. In this session, I will guide you through an example using the application called Hypertony Explorer. And this session is basically introducing you to this project. So what this project is about? So this project is based on the real research project in a collaboration between DISA research group at Linnaeus University and region Kronoberg. And this project aims to develop an AI-based decision support system to help healthcare professionals to identify individuals with a high blood pressure, which has a risk of having high blood pressure. And this is one of the examples of the data science project. So where we have data to analyze and historical data about patients with hypertony diagnosis and without hypertony diagnosis and their measurements and experience of the high blood pressure. So the data that is used here is electronic health records data. It's a structured tabular data, and they are from region Kalmar only. So in our example, we will not use a real data. They are generated based on the real data, but they are not real data. It's a subset of data generated specifically for this project example, which is inspired by a real project example, by a real research project. So we have a data set as a 4 years period. So since we extract data from a database from electronic health records, we receive this data usually in a CSV format as a CSV files. And they are contained in 4 years period from 2022 to 2024. There are in total 150,000 of individuals, and they are all elderly people. And we have 3 data sets, 3 CSV files. So we call them 3 data sets. A patient data, where we have information about a patient, such as ID, Boolean variable, if this patient individual has hypertony diagnosis or not, 0 or 1, municipality where the individual lives, age, gender, RUP index. RUP index, it says how healthy is a patient between 1 and 6. 6 is very unhealthy and 1 is healthy. This index helps to prioritize patients in a healthcare system. And then we have a date. And then we have a time series data. So this data is about different events that happens with the patient, different recorded events like measurement of the blood pressure, and we have blood pressure consistent from systolic and diastolic blood pressure, the weight, length, if there is any medication prescriptions, any diagnosis, and so on. And the value, it's the value of that measurement. If it was systolic blood pressure measurement, then it will be the value of that systolic blood pressure measurement. If it was medication, it will be the code of the medication. So the data that we are going to work here is more only numerical or categorical data. And we have one more data set called map data. It is already pre-processed and ready file for creating the interactive map visualizations. So here how looks the data. We call it raw data because this is how they, for example, was extracted from electronic health records, which is a repository of the medical data. So we have a patient data containing 150,000 of rows. We have, as I told already, patient events containing this time series data. So we have 1 million events. Again, in real data, it will be much more rows here. This was just generated data for this example, And the map data, the difference between the map data and the patient data is that map data only contains patient with hypertony diagnosis, while patient data, there could be patients that has a high blood pressure, but they are without hypertony diagnosis, for example. And And this example is try to create a web application which will help visualize this amount of data in a meaningful way for the end user. So in our case, end user, it is also medical data science who want to see an overview of distribution, for example, of individuals with a hypertonia diagnosis over the Kalmar region. And as well as having somehow visualization of this time series data, of this events data, to see a full picture of what's going on with the individual over the year, for example. So for doing this, we will create a web application using the following frameworks. On the front end, we will use Angular, and the front end will provide the visualizations of these data sets in a meaningful way. And here we will use two libraries, Apache eCharts and Plotly. On the back end, we will have a Flask Python, because the Python language has already a lot of libraries working with the data for analysis, doing data analysis, doing machine learning, and so on. So the Python language is a kind of native for data science, but not so native for web development. So there is a Flask, which is a web framework, but the language is used Python. The application flow here is, so on a web application in the front end with Angular, it will be used for showing the visualizations to the user, and they will be interactive. So instead of looking on a CSV file, because it's very difficult to find there that information, the web application will allow us to filter the data, select the data of interest, and visualize them in a way that you can get a quick overview of the individuals in this data set. It will send the request to the backend for getting the data for visualization. The backend in the Python will load the data from CSV files, pre-process them, and prepare them that could be ready to be consumed by the visualizations on the front end. This is a simple overview of the application flow. And now I will show you quickly how the example looks like. So this is our example. So it has, it has a map of the Kalmar region, and it shows the percentage and also number of people having the diagnosis, hypertonia diagnosis in this year, 2022. So we can also check the distribution on different years and see if there is some huge difference between it, or how it's evolving through the years. In the second tab, in descriptive statistics, we can also see more detailed information about the individuals for that specific year, for 2020 year. So here, but still for all individuals, for every region here. So here we have, can see the distribution of the age. We know it's already elderly people, and since it is generated data, they are generated like equally, so which is not in realistic scenario. In realistic scenario, yes, the data will have a different shape a bit. It's usually like this shape. And here we have a number of individuals, and we can also see distributions of individuals with a RUP index. Again, 1 is a healthy person, 6 is not healthy person and requires a lot of attention and needs from the healthcare providers. Here we have a summary, calculated summary, which is also done on the back end. We just visualize it. It's like, okay, from these individuals, how many females, how many males, what is the average age, what is the average RUP index, and how many of individuals do we have during 2022. So basically, how many individuals visits the hospital. In the other two visualization, on the left side, we have a table which also represents some individual level. We can access every individual through the pagination. So we can see here I have 80,000 of individuals. It's interactive table. So when we click on this row, on the right side, we will see a graph using this time series data that we have, showing all events happening with that individual during the 2020 year. So here we have like systolic and diastolic blood pressure. We can a little bit make it more visible here. Diagnosis, weight, height, medication prescription, and something that has been done to prevent the high blood pressure. And here the red color means it's a high blood pressure, something wrong, and the green one is blue and is fine. We can also see what exactly the value of the high blood pressure it was, and as well as we can see like, okay, which diagnosis code, which medication, which length in centimeters, height, and then which, exactly the code of prevention of the high blood pressure, some procedure. So this gives an overview already of that individual over the year, what kind of events happened during the year, what's going on with the patient, and finds also some patterns and and also groups which will allow you maybe to group these individuals in different groups. One that has under control the blood pressure, like here under control it is green, and this patient has hypertonia diagnosis, but the blood pressure is under control, so this patient is not in high risk. Like here we see we have also a patient, and it is maybe fine, but still it is have some red indications. Also the RUP value here. So in the next example, in the next video tutorial, we will start to work with the front end and a back end at the same time for making the map, interactive map.